Thanks so much for joining this webinar. Once again, my name is Sergey Sokolenko. I'm a PM with the Amazon RDS team. Today we will look at the new high availability option for RDS SQL Server called MultiAEG. This webinar will help you to understand the architecture of a typical MultiAEG SQL Server deployment, a new high availability deployment that is spread across availability zones. You will see a demo of how to set up a highly available SQL Server instance. You will also see a demo of a failover from a primary database to a standby. This webinar is intended for database administrators, software developers, solutions architects, and technical decision makers. So if you are in one of those roles, you are in the right place. Let me just quickly promote this PowerPoint into presentation mode. A quick promotional message. You are invited to one of our AWS summits where you can learn about the AWS platform and new services. The next one available is in New York City on July 10th. We also have Tokyo, Brisbane, and other cities coming up. Now let's take a look at the tasks of a typical database owner. Running a database is a lot of work. The unfortunate news is if you do a good job, nobody notices. Starting from the bottom, you have to take care of building or provisioning hardware, doing OS and database patches, doing backups, building a high availability setup, scaling your instance in CPU, memory, or storage, and lastly, doing database and query optimizations. Now, the good news is you can automate many of these tasks if you move to the Elastic Compute Cloud or EC2. For example, you can spin up a EC2 instance and forget about things like building racks, server maintenance, and OS installs. You can now spend more time doing things like high availability, scaling, and application optimization. But often you still don't have enough time to focus on what's really the value add, the query and database optimization. Amazon Relational Database Services automated many of the remaining tasks. RDS takes care of OS and database patches, backups and restores, and scaling. In the past, when you chose to run your SQL Server database on RDS, you could take advantage of all the goodness on the right-hand side of the slide, but the only exception being high availability. The MultiAEG for SQL Server technology fills this gap and completes the set of services that Amazon RDS offers to customers. MultiAEG for SQL Server is based on SQL Server's native mirroring with many improvements to ensure production quality in the cloud environment. When you build a high availability environment yourself, you have to potentially do 100 manual steps, including setting up the primary and standby instances, creating and managing DNS entries, detecting and reacting to failure conditions, and rebuilding your hardware in case of errors. Amazon RDS MultiAEG makes creating and operating highly available SQL Server instances as easy as selecting a yes in a drop-down in the AWS Management Console. Here's a diagram of an application that relies on RDS for SQL Server for its database layer. The application is running in Amazon Elastic Compute Cloud. The database is running in Amazon RDS, and both are located in Amazon Web Services US East region. The application is configured to connect to a SQL Server database using its endpoint name. Because this is a MultiAEG deployment, Amazon RDS is synchronously replicating the data in the primary database instance to a standby. The standby resides in a different availability zone, or AZ. Each AZ runs in its own physically distinct, independent infrastructure and has high-speed network connectivity to the other AZs in the region. Now let's assume a service disruption occurs that affects the primary. Amazon RDS will automatically fail over to the standby. The DNS name of the endpoint remains the same, which means that your application doesn't have to be reconfigured to connect to the standby. Instead, it must simply retry the connection. Database operation will typically resume in 1 to 3 minutes. Now let's watch a demonstration of creating and configuring a MultiAEG SQL Server database. For this, I'll switch to the AWS Management Console. And I will click on the Launch a DB Instance button to invoke a database creation wizard. I will select SQL Server as the engine and then choose the Standard Edition for creating my instance. FYI, MultiAEG for SQL Server is available with both the Standard Edition and the Enterprise Edition of SQL Server, but for this demo, I will choose the Standard Edition. On the first page of the wizard, the RDS console will ask me whether I would like to use this database that I'm creating for production purposes. If this database is for production, the wizard will recommend that I select MultiAEG for high availability and provisioned IOPS for performance. We already reviewed what MultiAEG is, but let's look at what provisioned IOPS do. They allow you to allocate a specific number of input-output operations for your writes and reads from the database. In this screen, I will confirm the yes and continue. RDS allows you to bring your own Microsoft license, or you could also choose an offering from RDS where the license is part of the hourly fee. I'll choose the license included model for this demo. MultiAEG available with both SQL Server 2012 as well as SQL Server 2008 R2. I will select SQL Server 2012 for the demo. The wizard will recommend an instance class that is optimized for MultiAEG. I will keep the recommended instance class of M3X large, but you're free to change it. I will also keep the MultiAEG deployment selection set to yes. I will enter a new database identifier and call it SSO25M and enter my new master username and password. And then click Next. On this screen, I'm able to enter advanced settings such as choosing virtual private cloud for better security, the backup and maintenance window, and so on. I will keep these proposed settings as they are, as they allow me to run and operate a fully functional SQL Server instance. When I click Launch, RDS will initiate the creation of the SQL instance. Let's examine its details. Notice that the MultiAEG setting for this instance is set to yes. We don't have the endpoint name yet, but it will be updated shortly and will be available in this field. Once the MultiAEG setup is completed, we'll also see the primary availability zone in this field and the secondary availability zone in this area. I will come back to this instance a little bit later, but let's look at some tips and tricks for operating MultiAEG instances in RDS. Now that you have a new MultiAEG instance, it's time to adjust your application architecture to a setup that takes advantage of the high availability. If you are an RDS customer, you'll typically start with a 3-layer architecture with a load balancer on top, an application in EC2, and a single AZ RDS database. You're well protected against failures of one of your application servers. But what if there's a data center or AZ-wide event, and your database or all your application servers are in that AZ? Here's a more resilient architecture. In this revised application architecture, you create a multi-AZ database instance. The primary will be placed in one AZ and the standby in a different AZ. You then distribute the application servers across all AZs of the AWS region and connect it to the primary database. Let's assume the worst case, when the AZ1C, where the primary resides, becomes unavailable. In this case, RDS will automatically detect this failure and initiate a failover to the former standby in AZ1B. RDS will also recreate a secondary in one of the available tertiary AZs. Because the endpoint name remains the same, your application server will, after a short while, reestablish connectivity to the new primary. Here's how you speed up failover times with Amazon RDS MultiAEG. Failover typically consists of 4 phases: failure detection, promoting the standby to the new primary, updating DNS so that the endpoint CNAME points to the new IP of the new primary, and crash recovery on the new primary. Sometimes, when you fail over during a very large transaction, there's a lot of crash recovery to do on the primary. And since crash recovery time is a function of storage, it is very beneficial to operate your multi-AZ databases on provisioned IOPS. Again, they allow you to deliver a predictable performance because you reserve a specified number of I/O operations for your reads and writes. It's also very easy to keep track of failovers. When failovers occur, RDS will emit a so-called database event. You can sign up for notifications on specific event types, including failovers, and get them delivered to you by email. We also recommend that you test your application's preparedness for failover manually. You can use a command line interface to initiate the manual failover. This command is called RDS reboot DB instance, and you need to specify the force failover flag to achieve a multi-AZ failover instead of an actual reboot of an instance. You can also use the RDS management console to initiate a failover. Note that the failover action is called reboot, and by checking the failover checkbox, you will instruct RDS to perform a failover to the standby instead of a reboot of the primary. Let's see a demo of how this would work in real life. I'll switch back to the RDS console and pick a mirrored instance that I created previously. It's called SSO21M, and its primary availability zone is in US West 2A, while the secondary availability zone is in US West 2C. Also, note the endpoint name, which starts with SSO21M and ends with the port of the database. I will connect a SQL client to this instance, and I will use the SQL Server Management Studio as my SQL client. Let's check that the entry in the server name corresponds to the endpoint name of my instance. And yes, indeed, it's called SSO21M with the remainder of the URL. I will enter my master username and my password, and click Connect. In my test database, I have a database called sales DW with a set of tables, including one called customers. I'll open up the query editor to execute a very simple select command on this table. And here you go. I have a single record, so the connection is working. Now let's go back to the RDS console and initiate this manual failover. The easiest way to accomplish this is by selecting the instance in the instances list and choosing the instance action dropdown, which will offer you to select the reboot command. In this screen, I will choose Reboot with Failover and click Yes, Reboot. As you can see, the database has been put in a failover state, and it's being failed over to the secondary. Let's go back to the SQL Server Management Studio to check what happened to the connection. I'll execute the same SQL statement, and as expected, I got a transport level error that indicates that the connection has been interrupted by this failover. Let's review what is happening with the instance right now. If you remember one of the earlier slides, there were 4 phases to the failover: failure detection, standby promotion to the new primary, DNS updates, and crash recovery on the new primary. The first phase, the failure detection, is obviously not necessary during a manual failover, but the rest of the work still needs to be done. Remember, one thing that you can do to expedite failovers is by using provisioned IOPS. Provisioned IOPS help you reduce the time that is necessary for crash recovery, which overall reduces the time for failovers. One place to monitor the status of a manual failover or any kind of failover is the database events page. I'll switch back to the RDS Management Console and go to this events page. As you can see, the failover has already completed, as indicated by the action or the notification in the screen. Let's check what the new primary AZ and the secondary AZ are. The new availability zone is US West 2A, with the secondary zone being US West 2C. As you can see, the endpoint name has not changed. And so if I go back to the MySQL client, I expect the connection just to work again without any changes. Here you go. The SQL statement has executed successfully and returned data. Note that I didn't have to change the endpoint name again. So this means that your applications can just simply rely on a single endpoint name without the need to track different IPs for the secondary and the primary. Let's switch gears and go back to reviewing a couple of frequently asked questions that customers ask about MultiAEG. One of the questions is about the supported database editions and versions available with MultiAEG. We support the SQL Server Standard and Enterprise editions and SQL Server 2008 R2 and 2012. In terms of supported AWS regions, We are available in US East, Northern Virginia, as well as US West, Oregon, and EU Ireland. We are planning to support other regions in the future. Another question is about the ability to set up MultiAEG across multiple AWS regions. Today, cross-region MultiAEG is not supported, but if you are interested in cross-region disaster recovery, you should try our cross-region snapshot copy. And the last question that we typically get from customers about MultiAEG is about managing users, logins, and permissions on the secondary. The good news is RDS will automatically replicate changes on the primary to the secondary, including users, logins, and permissions. So you don't have to do it yourself. To summarize, if you run production and pre-production databases and need a highly available SQL Server instance, I encourage you to sign up on our homepage, awsamazon.com, RDS SQL Server. That web page also has FAQs and data import guides for each of our available database engines. In terms of next steps, once you signed up, I encourage you to create a test environment for MultiAEG, starting by snapshotting your existing database if you are a SQL Server RDS customer, then restoring this database snapshot to a test instance, converting it to a MultiAEG instance, and adjusting your application to retry database connections. That's pretty much the extent of all the work you need to do to convert and start using MultiAEG in RDS. This concludes my presentation of RDS MultiAEG, and I'm happy to take your questions now.
Thank you very much, Sergey. There will be a 60-second pause while we get set up for the Q&A portion of the session. So please stay with us. The line will be mute for 60 seconds, and then we'll be right back with a brief opinion poll to get your opinion of the webinar today, plus live Q&A. Okay, everybody, welcome back. Now, in your browser, you're going to see some poll questions. We'd like you to give us your honest feedback on these because we'd like to improve our webinar series for the future. The first question is, how satisfied are you with today's webinar? Please take a moment to give a quick response, and then we'll move on to the next question. Okay, let's move on to the next poll question out of 3. Let me ask you for your response to the question, how effective was the presenter in communicating the content? Please take a moment and respond to this question in your browser window. Okay, let's wrap that one up and move on to the last question. The last question for today is, tell us please about the types of topics that you would like to learn next. Okay, thank you very much for your responses. We'll wrap up the poll section of the webinar now. We thank you very, very much for your feedback. It's greatly appreciated and it will help us improve our webinar platform. We will now start the Q&A portion of the webinar. Back to you, Sergey.
Thanks, Brian. One of the questions is about enabling MultiAEG for existing instances, and it actually says MySQL instance, but I presume the question is about SQL Server instance. Yes, it is possible to convert an existing single AZ SQL Server instance into a multi-AZ SQL Server instance just by going into the modify screen and picking what we call an option group that includes the mirroring option in it. That's the extent of the work required. One page, one selection of a value in a drop-down, and we automatically will start converting your existing single AZ instance into a multi-AZ instance. You might want to do a backup, do a snapshot of your database before this work. Perhaps you would like to, one of the paths would be creating a test instance by restoring a snapshot into a separate database instance and then promoting it to MultiAEG so that you can test your application readiness for MultiAEG. But the short answer to your question is yes, it is possible to simply convert a single AZ into a MultiAEG database. The next question is about running MultiAEG instances in VPC versus EC2 Classic. Yes, it is possible to run MultiAEG SQL instances in both VPC as well as EC2 Classic. So you don't have to pick one or the other. If you prefer to run to operate in EC2 Classic, you can continue creating MultiAEG instances in that environment. One question is about using MultiAEG with log shipping, or maybe perhaps using log shipping to create a cross-region read replica, perhaps. The answer is, at the moment, this functionality is not available, but it is on our radar, and we're continuing to strive to improve our service for our customers. So stay tuned. One question from customers is, why don't you have MultiAEG available for RDS MySQL? Now, I do need to clarify one thing. MultiAEG is available with all our RDS engines, including SQL Server, but also MySQL, Postgres, and Oracle. So you can definitely create MultiAEG instances for RDS MySQL, as well as Postgres and Oracle. Let me pick another question. One question is about using the standby instance for reporting and other functions in a possibly read-only capacity. The answer is the standby is not readable in this configuration. It is really truly used for failovers, and you will not be able to access the standby for by other applications or for reporting and executing SQL queries. One question is about the overhead that the synchronous replication will impose on a MultiAEG database. The overhead relates to the additional travel time or network travel time for transactions to travel between the primary and the secondary. But you have to remember that this traffic is local to the data center, the availability zone, so it's really fast. But yes, there's a latency penalty incurred by synchronous replication. It's typically within 2 to 5 milliseconds. That's approximately the impact that you will see on your transactions. In terms of the overhead on IOPS, multi-AEG instances will incur double the I/O operations of a single database instance, just due to the fact that you have two databases doing the same operations, reads and writes to your disk. Another question is about importing databases from EC2 SQL Server to RDS. We have a couple of options, and we have a section in our database documentation on in the AWS documentation area. One of the possibilities would be to, if your databases are small, just to use the data export and import wizard available through the SQL Management Studio. If your databases are larger, then you can use the DCP tool to export data into flat files and then import those files into your new RDS instance. There are a couple of open source tools you can use and available on Code Project that are simplifying the data migration from one environment to another environment. So just do a quick Google check and search. You'll find a couple of references. The next question is about the approximate failover time between the primary and the secondary. We've seen a typical failover time of 1 to 2 minutes. As you saw during my demo, the failover occurred pretty quickly. While I was talking about the qualities and the different phases of failover, the failover already occurred. So typically we see 1 to 2 minutes failover time. We do have a set of questions related to using the secondary for read operations. I believe I answered these questions already. Unfortunately, that's not available at the moment. The standby or the secondary is only used for high availability, so it's not a read replica similar to what we have for MySQL or Postgres. The next question is about the instance name, and it goes like this: Does the instance name change when you fail over? The answer is no. The instance name does not change. The endpoint doesn't change. The instance name doesn't change. You're pretty much exposed to the same instance in terms of naming. We do take care of DNS changes. So one of the big benefits of multi-AEG implementation in RDS is that we take care of DNS changes. So all your naming remains the same. The next question is about updating stored procedures and permissions and whether they are replicated to the secondary. The answer is yes. All the database objects within your user databases are replicated, including tables and data in the tables, all the DML and all the DDL operations in your user databases, including stored procedures and including permissions as well. And last but not least, users and logins are replicated as well. Another question we had in the audience was about availability of relational database services for just MS SQL, Microsoft SQL Server, or whether we have other engines supported in RDS. The answer is we have 4 engines in total today: SQL Server, Oracle, MySQL, and Postgres. Next question is about a multi-master replicated database setup. Today, we do not support multi-master setup, but we are keeping this on our radar and constantly improving our service. So stay in touch and keep updating, keep participating in our webinars. We will share the information with you once we have this feature available. Steve is asking what the maximum database size is for RDS SQL Server. Today, we support databases of up to 1 terabyte in size. So that's our maximum. If you have larger data sets, then one thing that you could do is dividing your data set into sharded databases and running such a setup on RDS among several instances. That's a better architecture for the cloud anyways, because you typically want to be able to scale up and scale out your installation into multiple instances depending on the workload that they receive. The next question is about the availability of reporting, analysis, and integration services on MultiAEG. Today, we do not offer these options with any of our RDS SQL Server instances, either single AZ or multi-AZ. But what you can do is you can operate your RDBMS on RDS and then run reporting or analysis or integration services on a EC2 instance. That's what many of our customers do. The next question is about the efficiency of database mirroring and whether there is any data loss when the failover occurs. There is no data loss because we run synchronous replication, so it will never fail over if the secondary is not in sync with the primary. Synchronous replication has the good quality of keeping the primary and the secondary always in sync, and so there's no data loss when there's a failover. The downside of synchronous replication is obviously this penalty of commit latency, but as I said before, this latency is about 2 to 5 milliseconds, and it's being the network is being traffic is done through very efficient inter-AZ network connection. I'm sorry, intra-AZ, within AZ. The next question is about a comparison of performance between a local database against a RDS database. You know, our customers see very, very comparable performance when they run on-premise applications or on-premise databases versus RDS databases. It's pretty much the same thing because we are setting up or launching a EC2 instance and installing our RDS stack on it. So you do get a virtual machine that is similar to what you would get on-premise or on EC2. Performance-wise, we see very comparable results. The next question is about a setup where the IIS server, the web server, is running together with SQL Server on the same instance. So that's a current setup of a customer. So the question is about how to replicate this in the AWS environment. Now, what you want to do here is you would want to run your database on RDS while deploying the IIS server to a separate EC2 instance. It's a more scalable setup anyways. It gives you two layers for the application and the database. You can scale each layer independently, and there is better security because the web server is not running on the same machine as the database server. The next question is about cross-region backups. I would like again to remind you that you can use a newly released feature called cross-region snapshots. The cross-region snapshot or snapshot copy. Cross-region snapshot copy allows you to pick a snapshot in, let's say, the US West region and copy it into the Sydney or Tokyo or EU region using the efficient network connectivity of the AWS network. You can set up the snapshot copy to be every hour, every 15 minutes by using the command line interface, and so creating a disaster recovery solution for your enterprise. Another question is about accessing and downloading database backups. This feature is not yet available, but stay in touch. We are constantly improving the service. The next question is about encryption with RDS SQL Server, including using the AWS encryption, as well as supporting the SQL Server TDE in the Enterprise Edition. Just to give you a quick overview, RDS SQL Server allows you to encrypt your databases using the transparent data encryption, which is the native encryption technology provided by Microsoft, if you have an Enterprise Edition database. So this functionality is currently available both in single AZ and multi-AZ configurations. So you can run encrypted databases that are also highly available. Now, John, who is asking this question, is asking about going beyond TDE and using EBS encryption that was recently launched. This functionality is not yet available with RDS, but we are improving the service, so stay in touch. And once we have something to announce, we'll share the news. The next question is about reserving multi-AZ instances or making reserved instance purchases. Just again, as FYI for attendees who are not yet RDS customers, reserved instances allow you to pay a significantly discounted price and make a reservation for an instance for either 1 year or 3 years. The advantage of such a reservation is the significant discounts that you can realize. If the multi-AZ configurations are not available in the reserved instances page, then do check which region you're running in. Remember that multi-AZ today for SQL Server is available in 3 regions, which is US West, Oregon, US East, Northern Virginia, as well as EU in Dublin. So those are the 3 regions which have multi-AZ enabled, and in those regions, you should be able to make multi-AZ reserved instance purchases. The next question is about estimating the recovery time without going through a trial and error phase and just maybe taking as inputs the database size and provision tie-offs. Actually, the recovery time is not really related to the database size, but the transaction load. So if you have a light transaction load on your database, then failover times can be as quick as 60 seconds. For medium transaction loads on your primary database, remember, recovery time depends on crash recovery of the primary. So that's where the variability of the recovery time comes into place. So if you have a medium intensity transaction load on your database, then we've seen typically higher than maybe between 2 to 3 minutes failover times. There are examples when a customer could be in a very large transaction and that transaction requires a significant crash recovery on the new primary. And so those times, those recovery times can be larger than 3 minutes. One customer is asking, one attendee is asking to explain in more detail the multi-region snapshot. I already talked about it a little bit, but just to remind you, in Amazon RDS creates automatic snapshots, backups of your databases and stores them in S3. You can also initiate a manual snapshot of a database and they will again be stored in S3. You have access to these snapshots. You can always do an operation called point-in-time recovery or recovery from a snapshot, which will take this backup and create a new instance and populate it with the selected snapshot. Now, one feature that we added recently was copying this backup snapshot from one region to another region. It's actually pretty simple. You go to the snapshot screen, you choose the copy operation, and it asks you to specify the target region. Let's say you start with US West and you would like to copy a snapshot to Europe or to Sydney or to Tokyo. So you will choose the target region being Tokyo, Sydney, and RDS will initiate a file transfer of this snapshot into the target region and then complete the operation by storing this file in S3 in that target region and making it available in the console of the target region. So you can always restore and create a new instance in your target region, which could be Tokyo, EU, Singapore, Sydney, restore and create a new instance from a copied snapshot. One question was about doing point-in-time recovery from or to a different RDS instance. This functionality is currently not available, but you can create from a snapshot or from a running instance, you can initiate a PITR operation, a point-in-time recovery, and specify any point in time within the backup window, and we will create a new instance for you and restore the most recent snapshot and all the transaction logs to that new instance. Once the new instance is created, you can remove the old instance. We have a question about availability of MultiAEG in the Northern California region. We are currently not offering MultiAEG in that region, but that's stay tuned. We are working on improving the service. One question is about the mirroring technology that we're using as the base for MultiAEG. And the question is whether this mirroring technology is proprietary AWS technology or the standard Microsoft SQL mirroring. We are using the native SQL Server mirroring technology from Microsoft, but we improved it significantly to run and operate a quality production service in the cloud. One question is, one attendee is asking to clarify whether the use of elastic load balancer is required for MultiAEG. It's definitely not required to use MultiAEG SQL databases. It's more of a recommendation for a resilient application architecture where you have redundancy on both the database layer through MultiAEG as well as on the application layer through using elastic load balancer. So ELB is not required, but it is a useful tool to achieve redundancy on the application layer. One attendee is asking about the improvements in mirroring that we've made and the comparison to building a mirrored setup in EC2 versus using a RDS MultiAEG instance. Well, one of the improvements is that RDS is running the primary, the witness, and the secondary in separate AZs. So we actually use 3 different data centers to run the triple of hosts that are required for mirroring. Don't forget, for mirroring, you also need a witness process, which kind of coordinates the failovers. So one thing that we improved is we are running MultiAEG in 3 availability zones. Another improvement over standard mirroring was testing all the possible error conditions, network partitions, hardware failure, software failure, SQL Server unavailability issues, and just covering all the possible combinations of events that can happen to your database. We really invested into testing all possible combinations and created error handlers who are capable of dealing with pretty much every situation. And maybe as the last improvement that I could mention quickly here was the introduction of additional replication of additional database objects, for example, users, logins, and permissions, which you don't usually get, or which you don't get through standard mirroring and need to set up yourself. I'll take maybe 1 or 2 more additional questions and then turn it over to Brian. One attendee is asking whether the failover or the replication is synchronous and whether the control is returned or the transaction is committed only after the secondary I/O has been confirmed. Yes, replication is synchronous here. We chose synchronous mirroring to implement high availability. This means that we will not commit a transaction before the secondary confirms that the block has been written. And the last question is, do we support transparent data encryption only if we bring